Hello, my chemistry faithful. Welcome to oxidation and reduction. This is unit 9, I think, for us, right? I think so. I think that's unit 9. So we're going to delve into electrons moving from one side to the other. So this could be a very difficult unit for you. This is a pretty easy unit for you. This is the unit where we will add and subtract -1 a lot. So remember that whole electron thing at the beginning of the year? Well, it's going to come into play here, kind of on steroids. So I hope you can handle adding and subtracting -1, but let's get to it. What we're going to learn and how we're going to do it. Okay, overall arching themes. How do oxidation numbers change in the single replacement reactions? They will change. How does a battery turn chemical energy into electrical energy? We will learn how batteries work. Can electrical energy cause a chemical reaction to occur? Interesting question. What makes a single replacement reaction spontaneous or not? There's a good word, spontaneous. I like that. What happens in single replacement reactions in general? Just a general reaction. And how do you build a battery? That would be a cool lab for us to do, would it not? See if I can sneak that one in there. I'm going to try and see if I can round up those materials. When you are done with this unit, you will be able to say, I can assign the correct oxidation numbers to ions within elements and compounds. I can identify how the oxidation numbers change after a single replacement reaction. I can identify and write oxidation and reduction half reactions to show the movement of electrons. I can identify oxidizing and reducing agents within the reaction. I promise you this one is backwards, so this one you might want to put a star by. It's tough. If you get the oxidation and reduction down, then the opposite is the agents, but we'll get there. We'll get there. I can use table J. We learned that a little bit about it last unit, which metals react more, which ones react less, to determine if a particular redox reaction will be spontaneous or non-spontaneous. We call the whole unit by default redox, oxidation and reduction. Red is reduction, ox is oxidation, but that's, instead of saying ox-red, we call it redox. Which kind of works out. Okay, so you're going to hear me say redox a lot. All right. You will be able to say, I can identify all the parts and functions of an electrochemical cell, or in other words, a battery, because it produces chemical electricity. Sorry, let me go back. Chemical energy from electricity. It doesn't produce chemical electricity. There's no such thing. Yo, milk, slow down. I can state the direction of flow of electrons through said electrochemical cell, and more importantly, write the redox half reactions for that cell. That's the real deal Holyfield for this unit right there. I can identify the function of a power source in a working electrolytic cell. And that brings us to our assignment tracker. So here we go. Normal vocab quiz. We have an oxidation numbers Fogel. Do some more homeworks. Then there's going to be a simulation lab. And that's it. I guess there isn't another Fogel here. No, there is just the one Fogel, I think. And then you'll have your reference table quizzes and your castle quizzes and like normal. I am going to try to sneak in a battery lab. I know that we've had the written page materials to do a battery lab forever. It's the physical pieces that I need. So I'll see if I can round some of those up, and maybe we'll add another lab in here just for fun so you guys can get your hands on a battery and test out some different metals, maybe see how they work. But that's it. Okay. That's all, folks. Peace out. I know you can see me while I find the button, so I will sing my song. Find a button and